Hello and welcome to my tutorial on Wireshark. Today I'm going to briefly talk about the different uses for Wireshark, what it is, and why it's really useful today if you are in, in the IT field or you're an internet technician or you're configuring networks. So Wireshark is a packet sniffer, and what they do is all data that's sent over the network, if you're on the internet, it is sent in packets. And packet sniffers like Wireshark can take a look at those packets being sent to and from your device and tell you kind of what's inside of them. They'll have data of hardware information like source and destination ports. They're going to have your different IP addresses for your source and destination and your MAC addresses. And there are going to be lots of different types of packets that you'll see with lots of different protocols. And it can be a little freaky, but once you know what all of them do, it comes a little easier. So packets with different headers have different types. This will be easier to understand in the future, but packets with different kinds of headers will be called different things like datagrams, segments, and frames. All these packets, they tell us all about the network traffic. And without a packet sniffer, you can't take a look at what's physically inside a packet. So we need to analyze packets, really, because if you're an IT technician and you're trying to configure a network, you're trying to set up devices to hook onto the internet, trying to test a connection, you're trying to, of course, detect forms of malware. Not everybody is going to need to do this. Mostly IT technicians are going to carry that responsibility. Normal end-to-end users generally aren't going to need to open a packet sniffer to figure out why they can't connect to the internet. OS systems usually have diagnostic tools that can easily tell you, what's wrong. Your router is not turned on, your Ethernet isn't plugged in, you turned your Wi-Fi off, whatever. So maybe completely unnecessary, but for people who are currently in the field and are actually setting up devices to communicate over a network, you need to make sure they're working and connected, and you need to see what kind of data that's being transmitted. And of course, luckily for the normal end user, you might not need to worry about malware because its rules are constantly being updated to catch it, and firewalls are always being updated with new rules. Just as how I tried to access a web page earlier to start this, to get a software for this program to do this video, and my firewall said I had malware, so I couldn't enter. So that's a kind of a neat example, but I could easily figure that out without opening up Wireshark. So I'm going to give a couple neat ideas of what you can actually do with Wireshark and how it is actually really, really useful. The first thing I'm going to show you with Wireshark is the ICMP protocol and how those packets are sent out and what they mean. So ICMP, Internet Control Message Protocol, they'll send what's called a ping request, which are hello messages basically. They'll send that to a IP address or a URL to test their connection, to see how long it takes for those packets to travel. It's also going to show you the different points that it stops at, the routers. So if we stop this, start a new one of this, open this up and do, we'll do Time Warner Cable, because it's right around the corner. So it's also going to send out DNS protocol packets, which are going to resolve the URL to its IP address so that we can actually connect to it. We can't connect to just a URL. So, oops, I might have made a little mistake there. So 4 packets were sent and 4 packets received, none were lost. It took about 71 milliseconds, and we can actually see that in here. You can see more of that here. What you can do is use this filter here. We can only look at the DNS packets if we want to. We can also only look at the ICMP packets, as you see here. And these are the different packets that came that were sent and received. If we do another one, this one, how about Washington .edu? Oh, make sure to do ping. It took about an average of 90 milliseconds. Again, we can see that here. Let's look at the DNS query. If we can see we got the IP address from here, and you can see all of those down here. The last one, let's try, what was it called? Moscow State University? msu.ru. See how long that takes. About 170 milliseconds. Yeah. So it takes a little longer for those to travel around the world. So that's how you would check your connectivity, the actual physical layer of that, and see what's going on. Another thing I'd like to quickly go over is the TCP handshake. When you open up Wireshark, you'll notice that a lot of the packets are either UDP or TCP. It's the transportation protocol. It's how packets are usually sent. So they have TCP packets have a checksum and error detection. So they'll make sure that all the packets are being sent, and if there are any that have not been sent properly or lost, they can request for the same packet to be sent again. Now, if you have, if it's UDP, and TCP is going to be a lot of HTML, like text data, while UDP is going to be a lot of, say, if you're going onto YouTube, looking at videos and streaming, it's going to be a lot of UDP packets because it's connectionless. It doesn't need to formally establish a connection like the TCP handshake will do. It just starts sending data and receiving, and there's no particular order that the packets are sent or received like there is for TCP. So I'll show you what the handshake looks like. Oh, actually, I can show you live. So if you see here, when connecting to the universities earlier, one of them we could see I sent out a SYN pack. So that's basically me asking, hey, can I connect to you? And they send it back to me. They're saying, hey, I got your request, and I'm acknowledging that I got it, and letting you know that it's okay. And lastly, I send back an acknowledgement that they acknowledged that. It's like saying, yeah, of course I can confirm that you're confirming this connection for me. Nice to connect to you. So I'd just like to quickly show you what it's going to look like if you try and go to YouTube and what kind of packets are going to be sent. So just connect it to YouTube. Start this going. Let's actually restart that. Just start from the beginning. Let's get all of this going. Alright, so let's take a look here. Already getting a ton of, like I said, UDP packets. Starting to gather all the information from those videos there. And we can see here, if we open this up, already in 25 seconds, there are 1,700. That's actually pretty low, because before I've done this, and about 80,000 were sent. So this is just an exception, but they are sent and received very fast, so they pile up very quickly. And like I said, usually it's going to be UDP for streaming and TCP for stuff like texting and email. So I'm going to talk about a couple different types of malware attacks, and one of them is being spear phishing. So when you try to access an website that may be running an outdated version of Windows Explorer or doesn't have proper certification, their connection is not secure. Usually you'll see SSL under the next to the HTTP URL. This sort of site may be uncertified, so the connection is not secure, and so the additional data that's being sent in packets may not be being analyzed. So they can throw in whatever type of malware that they want to, and usually they take the form of scripts, and I'll show you. So This particular spear phishing attack is called Aurora, and so if you look inside any of these TCP packs, you can see it gives you a bunch of different information, and this all looks fairly normal. If you go down here, you see all this jumbled code, and you would have to know from looking at previous packets in the past to know that this is not normal, uh, as well as this iframe here. Both of these things are highly suspicious and are red flags, so if you look here, they would have had to look, eventually find this packet. They would have had to look through all of these, and eventually come across this one, follow the TCP stream. You can see there's a Windows shell script that's giving admin ability to someone to drive C, giving access to their passwords. I don't know how many passwords there are on there, but that's something that you don't want to lose. So this type of attack would probably have been patched by now, since this is a sample capture of what a typical spear phishing attack would look like. So most of these are going to be caught. So you don't really have to worry about that. So another form of malware attack is called ARP poisoning, or the man-in-the-middle attack. So when you're trying to connect to a host and you're sending out an ARP request trying to get their MAC address, a third party will mask the host's MAC address as their own. So your connection is routed to them. So whatever data that you send over is going to just be sent to them. And I'll show you exactly what that looks like. If I can find this here on my desktop. ARP poisoning. So if you see here, we're trying to connect to the Cisco MAC address for Google. So it starts connecting, does all of this, and so eventually we start see we get the ARP request here. We start seeing this this other device, and eventually, once you've finalized the connection, you're connected to this one, Hewlett. But you want to be connected to Cisco. See, Dell is us, Cisco is Google, but we connected to Hewlett. So instead of sending our data to, or receiving any data from Google, we're going to be sending and receiving data from this computer without even us knowing it. So this last example of how to use Wireshark that I want to show you is very handy. It's a very relevant example of how you why you would use Wireshark in a day-to-day basis. So my dad writes software for pin pads just like these, and they send information like credit card information over to the processor or bank, and they send that information packets the same way that our computer does or any other device does. It has an internet connection, and it sends those packets and sends the same header information, the IP and MAC, source ports, and all that. So my dad figured out that the EMV issuer tag wasn't being sent in his data packets, and this tag is when, say, your credit card, you change your PIN code on it, or someone creates a faulty card of it and starts using it, and the bank is alerted, and they set a flag to your card. And this is supposed to be applied during the transaction when that information is going out to the processor. So he was able to look inside the packets, and I actually can show you those. The log right here. You can see the information looks just the same as here. You can see this one's 86 bytes, 54, 80, different packets that are being sent. So he was able to look at, decipher the information, figure out what was being sent and what wasn't. He figured out that the issuer tag wasn't being sent to the processor to let them know, hey, you can't use this card. So without Wireshark, he wouldn't have been able to do that. It's a very relevant example of how it's used today and how businesses can really benefit from using Wireshark, especially businesses that deal with these kinds of devices. Thank you all for watching. A quick recap. So we covered Wireshark. It is a packet sniffer. All data that's sent across the internet are in the form of packets. They're encapsulated with header information like source ports, destination ports, IP addresses. We can check the connection and the packet traffic by opening up Wireshark and looking at all the packets that are being sent across the network. We can get a good idea of what's the data that's inside them. Wireshark is useful for detecting different forms of malware, and it's very useful to check all the information that is being sent and received by a device, making sure nothing is being dropped and everything is making it to their destination. We can analyze all of that with inside the packet data.